There are discoveries that capture the world's attention for a few days. Others reshape entire branches of science. But every once in a while, a discovery appears that forces researchers to revisit ideas they once believed were firmly established. These are the moments that redefine our understanding of the universe. That is exactly what has happened with one of the James Webb Space Telescope's most remarkable observations. For generations, astronomers accepted that the universe's earliest history could only be reconstructed through mathematical models and indirect evidence. The first stars, the earliest galaxies, and the ancient stellar systems that emerged shortly after the Big Bang were thought to be forever hidden beyond the reach of our instruments. We could estimate what happened, but actually witnessing those events seemed impossible. Then Webb changed everything. While examining one of the deepest regions of space ever observed, the telescope uncovered something extraordinary. Instead of faint, featureless smudges barely visible against the darkness, astronomers found compact collections of countless stars located so far away that their light had spent billions of years crossing the universe before reaching us. These weren't simply distant galaxies. They appeared to be ancient stellar systems preserved from an era remarkably close to the universe's earliest stages of evolution. The discovery immediately raised an astonishing possibility. Could these objects represent some of the oldest surviving star clusters ever observed? If the answer is yes, they offer something scientists have sought for decades: a direct glimpse into the period when the universe was building its very first large stellar structures. Using Webb's exceptional infrared sensitivity, researchers identified what may be the most distant globular clusters ever detected. These tightly packed systems each contain hundreds of thousands to millions of stars held together by gravity, forming enormous spherical collections that have survived for billions of years. Globular clusters are among the oldest known structures in the cosmos. Unlike young star-forming regions, these clusters preserve a record of conditions that existed near the beginning of galactic history. They serve as natural archives, allowing astronomers to study how stars formed during the universe's youth. What makes these newly observed clusters remarkable isn't only their enormous distance from Earth. It is what that distance represents. Because light requires time to travel, looking farther into space also means looking farther back through history. Every photon captured by Webb carries information from an earlier chapter of cosmic evolution. The clusters identified in this study are being observed as they existed roughly 9 billion years ago, providing an unprecedented opportunity to investigate stellar systems much closer to their birth than anything previously available. Until now, observations like this simply weren't possible. Earlier space telescopes lacked the sensitivity needed to resolve such compact structures at these extraordinary distances. The ancient universe remained largely hidden behind technological limitations. James Webb has finally pushed beyond that boundary. Instead of relying entirely on computer simulations, astronomers can now analyze real stellar systems from one of the most important periods in cosmic history. These clusters may preserve clues about when the earliest generations of stars appeared, how rapidly galaxies assembled, and how matter organized itself after the universe emerged from its earliest phases. For decades, these questions were answered mainly through theory. Now they can be explored through direct observation. That shift represents one of Webb's greatest scientific achievements. Every new image provides researchers with information that previous generations could only imagine obtaining. Among Webb's first spectacular observations was an unusual galaxy that immediately attracted scientific attention. Unlike the familiar spiral and elliptical galaxies commonly seen throughout the nearby universe, this object appeared stretched into a long arc, its shape dramatically distorted by gravity. Around it were several tiny reddish-yellow points of light that almost resembled glowing embers scattered through space. Because of this distinctive appearance, astronomers nicknamed it the *spark galaxy. At first, the surrounding points of light seemed like they might simply be unrelated background objects. However, detailed analysis soon revealed a far more exciting explanation. These compact sources were physically connected to the galaxy itself. Located approximately 9 billion light-years away, the Spark galaxy is being observed during a crucial stage of cosmic evolution, when galaxies throughout the universe were actively growing and changing. Its unusual appearance wasn't caused by the galaxy's own structure alone. Powerful gravity from an enormous foreground galaxy cluster was bending and magnifying its light, allowing Webb to observe details that would otherwise remain invisible. Hidden within that magnified view were several incredibly compact stellar systems. Researchers carefully examined each one using Webb's advanced infrared instruments, measuring their brightness, colors, and physical characteristics. The results exceeded expectations.